Okay, so first thing first, hi. Second things, this won't be a technical talk. If you expect code, live coding, no, sorry, there won't be. It will be about the direction where we are going as an industry. Basically, our approach to serverless and to architecture itself. I will start with saying that serverless is nothing completely new. Basically, we as an industry are going in circles and rediscovering things. And there is the saying that from about the 70s, we didn't discover anything new. So more or less from the landing on the moon in '69. And it's actually true. All functional programming, aspect programming, microservices, serverless, we had it all. Let me show you. Basically, this is a server room. Quite old one, but still a server room. And actually, it's a serverless server room. There were no servers there. Actually, there were, but if you were a developer, you didn't program to a specific server. You had a bunch of servers, and you just created a program and scheduled for execution. That's all. You couldn't change the server, reconfigure the server, pick a server. You didn't have access to the server itself. In most cases, because they didn't even have an operating system. They were very simple machines. So, if we compare it, even now, we were and we are operating a terminal. You might say, well, this doesn't look like a terminal. Actually, it is. If you define a terminal environment is an environment where it's completely different from the environment on which the code will be executing. You don't have a AWS, Azure, or Google Cloud running on your server. We used to have environments which could be exactly the same as our production environments. If we go into the cloud, we don't have it. So basically, not much change between 50 years ago and now. And basically, we have time-based payments. Then, most of the systems were time-shared systems. So each university, each large institution had a slot number of hours a day they could use. If you start reading any biography of Wozniak, of Gates, and so on, they have one thing in common. All of them stayed late at night because this was the time of the cheapest time, and their schools could afford the execution time of those large servers. Now, we basically have the same, only in terms of money. If our budget is fixed, then the execution time of our serverless code is also fixed. It's limited. We can pay more and get more, but basically, there is a cap. And if you look at it, we are in the same place we were 50 years ago. We have an actual incentive for our code to be performant. We will pay less, we will execute way more code. And that's nice, because on-prem, we actually didn't have to think about it. We could just call our IT and say, give me another server. And they will do it, because our code was not linked to the performance. Then, and now, we actually see the numbers. We see how long each function is executing. And a lot of slow machines. Then, we had tape machines and so on. Now, also, the cloud is a vast amount of really slow machines. Why? Because it's economically feasible. It's way easier to have a lot of cheap machines than to buy the new i9 processor and have it. Because the i9 will depreciate way faster than the bunch of i5's previous generation. It just makes sense from an economical point of view. And if we have enough servers, then if one of them fails, we are good. If we have only 2 servers and one of them fails, well, we have a big problem. And this makes sense. it made sense a couple of 50 years ago, and it makes sense even now. Yeah, so if we had serverless architecture, and we now want to have serverless architecture, what changed? Why did we, apart from this awesome new idea, why did we change our ways? Money. This is the graph of CPU speeds over time. And this is the logarithmic view, basically. You can see, basically, from 1990s to the 2000s, you had about 15 times increase in performance. So if we were a company in the about 90s, and we wanted, let's say, to buy a warehouse solution or a computing solution, it would normally take IBM about 4 years to develop this on-prem solution and buy this huge amount of servers. It made sense when the curve was low, but here it didn't. Because by the time we got those machines, they were already obsolete. This drove us from about 80s to the idea of developing for future hardware. And the most prominent idea of developing for future hardware was Windows Vista. Windows Vista actually worked really good on mid to high level hardware, but it actually sucked on the hardware that actually most people were using. Why? Because by this time, the curve flattened. We are not making 10 times more performance each 10 years. It's not that each generation of hardware gives us huge benefits. It doesn't anymore. By the time of Pentium 4, we actually hit the thermal limit. Each CPU is not getting faster, we are getting more CPUs. But more CPUs means that we have to run the code in parallel. And it's not easy. Because for the last 30, 20 years, we used to basically run on one machine faster and faster and faster. We didn't have to change the code. And this actually made problems, because if we wanted actually to double or increase the performance by 10 times, we actually had to buy not 5, but 50 more servers. And running 50 more servers is way more complex than running 5. You can't do it by hand. So then came the 2000s, basically. And the coolest, most awesome keyword there was: virtualization. And there is something with humans in our nature, it's actually ingrained in our minds, that when we hear each new idea, we try to make fun of it, we try to not think of it, and we try to mock it. And it's completely normal. This is how we as humans behave. This is how the evolution, thanks to this behavior, we are skeptic to new ideas. Thanks to this, we don't eat anything that lays on the ground and looks shiny. And basically, the same is in IT. Only we have memes. And I remember that when virtualization came into basically existence, most developers said, my software won't run on virtualization, I won't do it, there's too much performance hits, so on and so on and so on. It actually didn't matter that their software was crappy and it crashed every 2 hours and had to be restarted, but everyone said, no, we won't run on virtualized machines. Now, we should ask why. It was easy, because developers thought that the computation server, that the data warehouse server looked more like this. Where in truth, it looked like this. This was the time of the server under the desk. This was the time of sticky notes on computers saying, don't turn off this machine, it's our production server. There is a real awesome story from more or less this time. 3-4 years ago, HP had a computation server, data warehouse system, consisting of 1,500 machines. They were running for 14 years without any restarts. And they said that, yeah, we should upgrade. So the first thing that they done is just to restart the machines. After restarting the machines, more than 30% didn't even boot up. The friction on the drives, friction on the ventilators and so on, caused basically them to be dead without any changes whatsoever. And in the 2000s, we missed the point of virtualization. Virtualization is its point. It's not to be faster, better, but it's to have the ability to move software between machines, to actually have 24/7 uptime, because we can move from this old server to a new server, the same machine, without changing the application, changing anything. We missed the point of it all. We mocked the idea because we didn't understand it. Okay, so then came the 2006. The cloud, the new fancy word. And as people, this was, I think, the most prominent meme that time. And it's a real awesome one, because it shows the point, shows how much we miss the point. Yes, there is no such thing as a cloud. There is just someone else's machines. But yet again, the point of the cloud is that those machines are not mine. I don't have to think about it. I don't have to care about them. I don't have to schedule maintenance. I don't have to buy hardware upfront, and so on, so on, so on. Taking care of machines is not my business value, unless I'm basically OVH or Azure or something like this. And we actually had many arguments that are still valid by this time. The cloud is slow. Yes, it's slow. The cloud is expensive. If you compare the VMs in Azure and compare the VMs in OVH, or compare the hardware prices in a shop, the cloud is expensive, and every cloud is expensive. But what we as developers didn't see is that each company has to encounter redundancy, failover, maintenance, and so on and so on. Each corporation is buying at least 5 years warranties for every production machine. Each gigabyte is duplicated at least 5 times, because it's on write, it's on different development centers, and it's on backup. When we counted how many gigabytes overhead do we have for one system, it was 1 to 10. That's a lot. We are not seeing those numbers. And this is the point of the cloud. Actually, to move the responsibility, to move what we don't want to waste time with. And the lack of understanding of cloud made that we moved to the cloud, we treated the cloud as a VM provider. We took our on-prem solution, basically picked it up, moved to the cloud, and we said, yeah, we are cloud ready. And every company, trust me, wanted to be cloud ready. So we basically were running on-prem solutions just in the cloud and paying a bit more. But it actually did change in 2013. Does anyone probably remember what happened in 2013? Amazon had to because then basically the cloud was AWS, had to upgrade its edge nodes, so the nodes that direct traffic to its cloud. And there were a couple of issues with it. They said that, yes, sorry, we have no idea how long it will last. And if you had your machines in different availability zones, which should give you uptime, yeah, that might not help. If you only have one machine, we will be down for at least 1 day. And this was scary, because on-prem, we didn't have 1 day uptime with someone else telling us that you will have it. Our IT guys could say that, but we could always say, no, you can't do it. And here, however almost you design your architecture, whatever you've done, you will have one day downtime. That's huge. But there was one company who was, let's say, less scared than the rest. It was Netflix. Now why? Because they had this, Chaos Monkey. Then it was their internal solution, basically a small application running on a production environment. Again, on production environment. That would run constantly and shut down VMs, shut down communication, change networking, and so on and so on and so on. They were constantly injecting failure into their architecture. So the failure on AWS side, they were basically more or less ready. From that time, basically after this outrage, Chaos Monkey is in the AWS documentation as the tool for testing cloud architecture. Now it evolved into basically the whole Chaos package. It injects latency, it injects poison messages, it kills VMs, basically crashes your software constantly. If your software crashes using the Chaos package, it will crash also on production. Yeah, so this was the time when we realized that the cloud is not a VM provider. It's not just a VM provider. It's a different way of thinking and approaching software, cost, and especially architecture. We went from something treating our VMs and systems like this to going to this. And as a side note, it was a very common analogy. And I remember on some podcasts a guy saying that, yeah, it's really good unless you are giving a talk in India. In India, use chickens. No one has any doubts with chickens. Chickens are okay. So yeah, the cloud showed us that we can have a lot of cheaper VMs, smaller VMs, less powerful VMs, and we will have to acknowledge failure into the software solution. There's no way around it. Okay, so now finally serverless. What year is the beginning of serverless? Come on. 16. You say why? Because normally, yeah, something like 2013, 14, even later. Because this was serverless at the start. When AWS started with their cloud, they started with two offerings: the compute engine and S3 buckets, basically blob storage. Totally simple API. You have HTTP API to add, remove, update, and get files. Blobs, basically. Nothing more, nothing less. But you didn't have any servers. Actually, of course, you had servers. But since the API was behind, you were using HTTP, you only had the DNS name. And DNS is just an alias to an IP. That's all. You don't have any access to the server. The server can change in any moment. That's serverless. You paid as you go. You didn't have to allocate anything up front. You didn't have to say, yeah, I'll be using 1 petabyte of data. No, you just can buy it and start using it. That's all. No pre-allocation, as I said. And auto-scaling. And what is fun? We didn't have to worry about it. What was not that fun? We couldn't actually change any parameters of scaling. It was what it was. We couldn't change anything in this offering. And those restrictions are good. And of course, we had high availability. AWS S3 and Azure blob storage have, I think, 5 nines as default. 5 nines of availability is 3.2 seconds a year of downtime. If you actually pay more, you will get, I think, 8 nines of availability a year. That's crazy. You can't have it on-prem. No way. being down for 3 seconds a year, I would say it's a quite good value. Yeah, but probably when I said serverless, you thought about this. Azure Function on, or basically AWS Lambda or Google Cloud Functions or something like, or other offerings. But this is not serverless. It's FaaS, function as a service. And again, when the whole movement of serverless came to being, we had MEMS, of course. And there's a quite big similarity between this one and the cloud one. It's on point, it's completely true, and it completely misses the point of serverless or FaaS architecture. It misses the point because now I don't have to think about the servers. It's not my responsibility. What's more, I can't change those servers. If I can't change the configuration, it means that I can't break it, I can't introduce security errors, I can't change something and forget about it, or basically any other things that as developers we constantly do. It's funny because when Facebook is publishing how many errors do they have each day, and on the day that developers are not working, the number of errors goes way down on production. Basically, Saturday and Sunday, least errors, and it's like 10 a day. Saturday and Sunday, 1 or 2 production critical issues on production. We are breaking stuff constantly. Having limits means we will break a bit less. Yeah. So let's go to the fast part. We have no server. Checked. We have no server. Actually, that's partly true. If you go, for example, to Azure offering, you can basically actually pick a server on which Azure functions will run. If you go to Google Cloud Functions, you actually are picking the capacity and the computing power of the server on which the environment on which the function will run. But remember, we are basically on the start of this journey and start of how computing and serverless came to being. Basically, you have to think about serverless, that serverless is a byproduct of each cloud provider having way too many machines and sparing them to each developers, saying that, yeah, we have a couple of hundred machines too many, so we can give you those. But since we have to be elastic, we'll only give you compute time. And since we are talking about compute, we are paying as we go. We are paying in terms of executions, number of basically triggered functions. We are paying also in seconds a megabyte. So how many seconds our system was up multiplied by the amount of RAM memory that we were using. This boils down to the fact if we are faster and using less memory, our system will be cheaper, way cheaper. Again, we don't have to pre-allocate. That's partly true. We can't pre-allocate, but there are some limits in every cloud offering. So sometimes it's good to say, yeah, we'll be scaling 1,000 times up. We have auto-scaling. It works. Actually, if you try to combine a serverless architecture with an on-prem architecture, where the serverless will try to communicate with the on-prem, you will kill the on-prem solution. The time for any Lambda function, any serverless function, going from 1 to 150 to 200 executions, it's a couple of seconds. No on-prem solution will scale that fast. And there is a catch because it's extremely hard to limit the number of executions in Azure Functions. Actually, in Lambda is the same. It's not designed to be limited. It scales almost to infinity. And if you want to limit it, it's really hard to do. And it completely misses the point. and high availability. Why do we have high availability? Because if the code that is running is only a couple of megabytes and it's not dependent on the operating system itself, it's very easy to move. It's very easy to spawn a new machine and so on, so on, so on. If you wanted to move a VM which is 200 gigabytes, it will take time. Sorry, that's the way it is. Okay, but there is another part of the whole puzzle to actually create an application which is basically, let's say, serverless. It's BaaS, backend as a service. What is it? It's all of the things that are all around our application. The service bus that we will be using, the storage mechanism, databases, ops, everything basically. You can go to any cloud offering and basically click and choose and build an application just from things that you will be paying as you go. It's not hard. It's actually quite easy, I would say. So serverless actually is your data, because your data is your value, plus function as a service, plus backend as a service. And this more or less should be enough to build a software solution. Yeah? Is it enough? I would say no, because there is one additional power of going basically cloud ready. This small thing and this small thing. Since you are being charged per execution, per time, and per megabyte, basically you have to see the billing. To be transparent, each cloud provider gives you the ability to look into how much computing power did you use. This is a simple website, but I'm betting that none of your production on-prem systems have a simple website to see what it done, how long did it take, and what were the parameters. It's a simple application, basically. But the ability to see what the application is doing just by logging into a website is way better than seeing and going through the logs. So each serverless offering has something that I'm calling OIaaS, ops in a service. Each service that is basically built per usage will have the usage in the website. That's quite awesome. And if it's not enough, you can go even further. You can go ops as a service. For example, application insights. The same is with Google, the same is with AWS, or you can even basically use a non-cloud offering like Stackify or something like this. But whatever the solution, you have one dashboard that you log into and see what your system is doing. And this is groundbreaking. This is the whole value, actually, of going serverless, of going as a service. Because time to develop a custom solution, way too big. Deploying a basically box solution on-prem, yeah, you can do it. But there are two parts of any solution, deployment and maintenance. If you have time and people to maintain such monitoring environments, good for you. But probably they don't give any business value, but are very useful for developers. So yeah. This actually makes serverless the microservices for the people. If you are trying to build microservice architecture in any corporation, which is not a software development corporation, you will fail. Those companies don't have the resources, money, and the incentives to actually build such solutions. Running 20 VMs for Kubernetes with pods and so on, it's quite hard. You have to have people dedicated only for those things. Okay, so let's talk about architecture, because basically we are talking about microservice. So architecture. What is the main point of architecture? Why do we think about architecture? Why are we changing architectures? Why are we basically going to software development conferences and talking about architecture. My theory is to contain this. This actually is a chocolate ice cream emoji, so not what you think. But basically, any software system that is used and developed will have some issues. And that's normal. We can't change it. That's the way it is. There will be some times where we will have to make some shortcuts, and we will have code like this. Yeah. JavaScript. Yeah. But those things happen, basically. So what's the problem? The problem was that if we go to the extreme and let's say use this code in a monolith, it's quite funny because each time when I'm doing a workshop on software architecture for different companies, I always give a survey just before. And the question I love giving is, when would you use a monolithic architecture? And then people like, never, absolutely, I wouldn't do it. And the next question is, why wouldn't you? And there are significantly less responses there. But the most common is, it's untestable. Well, I'm calling bullshit on it. Monolithic architecture is the easiest to test architecture there is. You don't have to integrate multiple systems. Everything is mostly in one code base and so on and so on. There's a different problem with monoliths, basically. Monoliths get old really, really fast. The issue with monoliths is that you have one code base, and 5 years from starting that project, you have to still obey to the ideas that you had 5 years earlier. Basically, so you can't change technologies. They are a bit harder to maintain, but the biggest issue with monoliths is that if you create one bad check-in, if you check in bad code, this will happen to the bad code. It will be smeared all over this solution. Why? Because we don't have any hard barriers between the systems. We don't have APIs. They are not running in on different servers. So it's really easy to smear the solution, and the solution would slowly degrade. Because if you have, let's say, 50 developers in one project, or 10 or 15, you can't go through each PR. You can't look at each code. It's unfeasible. This is the main issue with monoliths. They are really hard to maintain over time. So yeah, so if not monoliths, we can split those huge applications into smaller and smaller parts. Then they are way easier to maintain. They are way easier to reason about. They are just easier. But there is also a different way of looking at it from a financial point of view. Let's take Uber. Uber is famous for a couple of things. One of them is that they are losing $1 billion a quarter. Yeah. And also to a quite interesting approach they have. Uber currently is running about 10,000 repos on production. That's a lot. And they have approach that they don't change code on production. They only fix bugs, they don't refactor code. They are running hundreds and thousands of microservices on production. We might ask why. The answer is really easy when you look at what Uber has done. They scaled in 1 year from 300 developers to 3,000 developers. What they are trying to save is not money, it's time. It's way easier to write the service once we know how it is used, once again, and not change the systems that are using the old system, old APIs, and just keep it on production, and just develop new iteration of the service. Because if the old systems are running, if the old systems are happy with the service, then keep it. There's no incentive in actually changing it. The only problem is that you are spending a lot of money on maintaining it. But it's way easier to refactor a service and be sure that it is not used by looking at the usage logs on production. If the server wasn't used for the last half year, it's probably not used. You can kill the VM. But it's not a matter of architecture or something. It's a matter of business priorities. What you are basically saving. So let's get back to the monoliths. In here, basically, if we split the application, it's a bit better. But there's also one additional part why multi-service architecture is way easier to maintain than monolithic. And Microsoft, I don't know, probably by mistake, probably it just happened, put it really awesome in one of their graphics. Basically, because if we design any microservice or basically any service designed on messages, our application will be code plus events and data. We are separating those two. In a monolithic architecture, the events and data and code was in one process. If we separated those two, and basically this is going through a service bus of some kind, it's way easier to maintain. Because this is a hard barrier. If the service crashes, receiving the message will go back to the message queue. How to fix it? Easy. We take the code, fix it, replay the message. How to write tests? Easy. Just get the failing messages, write them as JSON, add to a test, and reply them on test servers. You have data from production-grade data. It's really hard to do in a monolithic architecture. It's really easy to do in a service-oriented architecture. Microservice, even better. But there is a problem with this approach, because if we go this way, we might end up with this. And this is the architecture of not that big of a project. All of those services are really small. But the question you should ask yourself is, do you have the knowledge and do you have the ops, do you have the time and so on to orchestrate all of it, to design all of it? Basically, the ideal of architecture is moving complexity. We as software developers can't get rid of complexity. It will be in the code or in the architecture itself. It's our decision where on this point we are putting our architecture. Here, when we have the knowledge, when we don't have experience, or basically somewhere here, where we have to read a lot up front and design a proper architecture. We might get it properly, we might miss it. Let's get an example of basically a difference between on-prem and a SaaS solution. This is my website for cooking recipes. It might be up, it might be down, cookie.pl. This is the way it looks currently. We have an IIS, we have a Windows service, SQL server, a website that is scrolling, and some Sol for full-text search engines. Quite simple, nothing too complex. Basically, how the website works is that there are two parts. One part is you can go in it, search for recipes, ingredients, and so on and so on. The second part is that it is scrolling around 1,000 websites and getting recipes from them. Basically getting HTML, trying to understand the website, trying to get the recipes, and so on, so on, so on. So let's change it. First, I would use a CDN. A CDN, so Content Delivery Network. Why? Because it makes my website run way faster. And it's just a few clicks away. Click, click, and I have a CDN. Something that 20 years ago you only went to Akamai, and without a couple of $100,000, they wouldn't even talk to you. Now you have it as a service. Next, I would use some kind of blob storage. Why? Because I'm processing around 1 terabyte of data and storing around 800 gigabytes of data. It's really hard to do it efficiently, but if you go as a software as a service solution, it's just offering. Using blob storage is childishly simple. Next, of course, some serverless just to handle the request. And I would use Node. And again, I'm a Microsoft mostly developer architect, or however should I be called. And I'm using Node. Why? For a very simple reason. Because Node, the cold startup, so the first startup of a function written in C#, F#, Java, and so on, is about 5 seconds. The first cold start of a Node function is around 7 milliseconds. The user won't even notice. That's the cold start happened. That's what I said. With Monoliths, I wouldn't be able to do it because if I have one code base, it's running in one process, and I can't change the architecture. I can't change the software technology to the problem I'm having. In microservice or in serverless, in this case, I can pick and choose the technology just for the specific problem. It's way easier. Do it. Don't be stuck to your architecture that you had or to the technology that you had. Pick the one that is proper for this problem. Instead of Solr or Elastic, there's a software offering basically giving full text search engines. Easy, point and click, and it's up and running. And some kind of database, in this case, Azure table storage. Why? Because it's extremely cheap. It's like not even a full cent per gigabyte. It fits. My solution has a strange characteristic because basically the most usage is basically from me parsing the website. And on top of this, I would basically use application insights. Why? Because if you don't want to invest time in logging into the servers and so on, it's way easier to have a ops monitoring system that will just watch over your solution and send you alerts that something is broken, that some dependency is running slow, that the requests are degrading, that the user response time is degrading. I don't have to look at the dashboards. I don't want to spend time looking at the dashboards. I will get an email. That's all. That's all. Or I can probably configure an SMS notification. Now for crawling. Yeah, I would use also Azure functions, but this time I would use C# and F#. Why? Because this logic is way more complicated. Writing it in Node, too much of a hassle, and I already have this code running. And those functions are running in the background. The user doesn't see it. And it's way easier for me to use F# with type providers to crawl and parse websites. It just fits. Next, basically some messaging system, in this case, Azure Service Bus, some blob storage to store the images, some search engine, and basically some table engines. But there's a problem. As I said, my parsing solution is very compute intensive. I'm processing about 1.5 terabyte of data. So I would pay a lot for those executions. I can use VMs. Now, this might be strange because I'm saying that I'm thinking about serverless architecture, and I have VMs. Well, yeah, but for example, I can use VMs in Azure. It's called low priority VMs. It's basically an idea that every cloud provider has additional resources, but they have to provision for some peaks. And every cloud provider has an offering where they will say to you, you can have this VM, but if we need it, we'll take it away from you and basically kill your code. On the plus side, those machines are about 90-something% cheaper than those machines, than normal VMs. And since I'm running in the background, and I can create them as I go, and since these processes are not visible to the user, if this machine is killed, yeah, whatever. I won't be charged for the time for being killed. Those VMs are built per second. Spamming a 12-core, 48-gigabyte machine for 2 hours will be quite cheap. If it fails, what else? I have everything that I have to do in my message queue. I will just restart the message. If my message processing engine isn't taking like 2 hours per message, I will still process something. I still have value, and I'm not built for the time that I didn't use. And of course, some application insights on top of it. Why? Again, so I don't have to think about it and monitor it all the time. Some summary. Basically, any serverless offering is not a silver bullet. It's quite hard. You will probably have to redesign. You will probably have to learn a lot. But actually, there is hope. From my point of view, it's the first software solution, software hosting offering that actually encourages us to have proper software architecture, to design our systems in a proper way and not pray that our machines won't die, to actually concentrate on the point that we wanted to do. Does anybody know who this guy is? You should actually know. It's Krzysztof Kieślowski, Polish film director. Actually, and why is he on this slide? He was asked long time ago, why was Polish cinema, Polish films way better during the communism, during the censorship? And he said a really powerful thing, that having restrictions, having limits, it's really good. Try to go to your business and get the specification, and imagine that they would say, design it the way you want. No limits, no restrictions whatsoever. Having too much choices is making us way more stupider, and is making each choice worse, basically. With serverless, basically, and which is service solution, there is something that Microsoft is calling the pit of success. You can't do certain things that you shouldn't have to do it. Things that you shouldn't have to do are way harder, basically, to do. Those things that you should be doing are way easier. Having proper restrictions is really, really good. If you go to a serverless solution and you see that you are struggling with something, or it's really hard to do something, that's because you are doing something wrong. Your approach and the mindset from going on-prem to serverless is wrong. Go back and rethink what you are doing in this moment. Don't try to struggle with the framework. My friend has a nice saying, the framework is not broken. If you are developing and saying, it's probably the .NET runtime fault, no, it isn't. It might be, it probably isn't, basically. The next part is knowledge. The thing that is different between on-prem solutions and what we are doing currently in the cloud is the fact that you have to have way more knowledge up front. To design a software solution in the cloud anyway, you have to actually read a lot. It's not like on-prem, let's deploy it and I will learn this library as we go. No, the cost of running it will kill you. If you are using those services not in the designed way, it will crash and burn horribly, horribly wrong. And the only way of actually making it run will be paying way too much money. And your business will actually see how much we are paying. We can't hide the cost. And additionally, now we are the ones who actually know how the data centers work. Now we are choosing the solutions. We can't hide behind the IT guys who gave us a crappy server. It's a time that we have the power to choose the solutions, and we are responsible for those things. So basically, buckle up and read a lot. And basically, delegation. Cloud is a delegation of responsibility. That's all. And this is the business value that the company that you are working for actually has. They don't have to think about certain things about which they don't want to think. Try to understand it and try to be okay with it. And the last thing is basically creating a SaaS solution and serverless solution. It's basically passing responsibility, not throwing away and saying, yeah, goodbye. So think about how you approach software architecture, how to go from on-prem to cloud, and think about it. Really intensive. So, yeah, that's it. And I will leave you with this cartoon. Any questions? Yeah. No. That's why I said that creating good restrictions is really hard. Of course, for economy people, no, they weren't. Yeah. Yes, there are. The main problem is that more and more cloud offerings are basically, the question was which services I'm not using. The problem that I'm having with especially Azure now is that more and more solutions, especially Cosmos DB, is moving to provision upfront offering. And I totally understand why they are doing it. If we want to have low latencies, fast response times for the cold starts, Microsoft and any cloud provider has to provision upfront. But the move towards basically provision upfront, for example, with Cosmos, for my solution doesn't make any sense because I'm having peaks and I'm having lows like zero movement whatsoever. This is one of the offering, and I'm struggling with the full text search because if anyone knows how Lucene works, it requires uptime. It requires to be in memory. So this full text search engine is also basically buying a VM. Those offerings. Answered? Any other questions? Okay, so let's grab some coffee. Thank you very much.